Hi everyone and welcome to eSchool Bell. In this video, we shall see question number 12 of exercise 10.2 of CBSE Vector Algebra chapter, where we have to find the direction cosines of a vector I cap plus 2j cap plus 3k cap. So let's take this vector as a vector equal to I cap plus 2j cap plus 3k cap. Now you have to find direction cosines. Let's draw a two-dimensional diagram showing this vector. Now this red one is the vector. This is as a vector. We are taking this as a vector. Now this vector will make an angle with the x-axis. That angle is known as the cos alpha. Then with y-axis, this is y-axis, x-axis, z-axis is cos beta, and with z-axis it is cos gamma. These are basically the cosine angles. So direction cosines are basically given by the formula L is equal to the value of the x coordinate divided by the length of the vector. Here it is the a vector. So this is for x-axis. Same way for y-axis is m is equal to the value of the y coordinate divided by the length of the vector. And for z-axis is n is equal to the value of the z coordinate divided by length of a vector. So here x, y, z are basically coefficient of I cap, 2 cap and 3 cap, I cap, j cap and k cap, which are basically 1, 2 and 3. And the length of a vector is given by the formula a vector is equal to, or magnitude of a vector is equal to root of x square plus y square plus z square, that equal to root of 1 square plus 2 square plus 3 square, that equals to 1 plus 4 plus 9, which is root 14. When we check the value of root 14, it will be 3.74 units. Okay, this will be the length of this vector. Length of this vector will be 3.74 units or root 14. Now if you substitute the values of x coordinate and the length of the vector, then you will get the value of L. So L is equal to 1 divided by root 14, m is equal to 2 divided by root 14, and n is equal to 3 divided by root 14. So the direction cosines for this particular vector are given by the values 1 by root 14, 2 by root 14 and 3 by root 14. This is the answer required as per your textbook. Suppose if they tell you to find the cosine angles. Cosine angles. The cosine angles are given as cos alpha equal to L, that equal to x divided by the length of a vector. And same way cos beta is equal to m is equal to y coordinate divided by length of a vector, and cos gamma will be equal to n, that is z coordinate divided by length of a vector. Then if you substitute the values of this, then cos alpha will be equal to 1 by root 14, cos beta is equal to 2 by root 14, and cos gamma is equal to 3 by root 14. So alpha will be equal to cos inverse of 1 by root 14. Then beta will be equal to cos inverse of 2 by root 14. And gamma will be equal to cos inverse of 3 by root 14. So if you find the values of cos, then you get alpha is equal to 74.5, beta is equal to 57.7 degrees, and gamma is equal to 36.7 degrees. See, for NCRT point of view, this particular step is not needed. Okay, if you finish until here, that is more than enough. Now I just want to show you this particular vector in three-dimensional format. For that reason, I just calculated these values. So we will use these values now. We'll use cos alpha, beta, gamma, and we will also use the length of the vector 3.74 and in three-dimensional geometry, and we see how this vector would look in three-dimensional geometry. Okay. Okay, now let's see this vector in three-dimensional geometry. Now here you have the same question. Okay, so the vector starts from the origin, which is 0, 0, 0, and until a point A, which is 1, 2, 3. So this vector we named this as A vector. Okay, and with coordinates 1, 2, 3. X coordinate is 1, y coordinates 2, and z coordinate is 3. Now let's see what angle it makes with the x-axis. This is the red one is the x-axis here, the green one is the y-axis, and the blue one, which is vertically upwards, that is the z-axis. So let's check the axis angle which it makes with the x-axis. Now if you see the angle which it makes with x-axis, the value is coming as 74.5. So this is the angle which this vector makes with the x-axis, and let's see the angles it's making with the y-axis and also the z-axis. The y-axis, that is from the green color one is the y-axis. From there until this vector, you're getting an angle of 57.69, which is basically 57.7 degrees. That is the value of beta we got, and for z-axis is 36.7. So z-axis is 36.7. So these angles are known as the direction cosines, and this angle is unique for this vector. Values of this direction cosines for another vector will only be same if that vector is parallel to this vector. So if there are two vectors which are parallel to one another, then they'll have same direction cosines. Otherwise, they'll have different direction cosines. Okay, and next one we see is what is direction ratios. Direction ratios are basically, suppose you extend this vector further, at different levels you will get different coordinates. These coordinates are basically known as the direction ratios. Like I'll show you here. In this vector, this point is point A, and with coordinates 1, 2, 3. Then when you extend this vector further, you get point B, which is 2, 4, 6, and you can still extend this further. Still extend this vector further. You can have C coordinates 3.57, 10.5, and D coordinate. So as long as you extend this vector at different points, it will have different direction ratios values, but this value will be proportional to the direction cosine. Okay, so whatever is the direction cosine, these values will always remain proportional. We can also shrink this vector from point A, and still it will have different direction ratio values. So basically it will have infinite numbers of direction ratios values, and only one set of unique value for direction cosines. Okay, that is the property of this direction cosine and direction ratios. Suppose you want to measure the length of this vector. Suppose I just want to measure from 0 to A. That length also you can measure it. So that will be, wait 1 minute. Distance from 0 to A is 3.74. That is what we got over here. Here we got as length of A vector, which is root 14. The value of root 14 is 3.74. Okay, so this is the length of the vector, and hope you understood the working of this problem. In case of any doubts or you want to clarify further, you can always reach out to me in the comments column, and I will try my level best to explain, give an answer to your comments. And also you can forward, in case if you understood this particular concept using the 3D vector calculator, then you can forward this particular video to your friends and fellow classmates who find difficult to understand the vector algebra chapter. Okay, thank you so much for listening. See you in the next video.